is right around 9 o'clock in Eastern time now. Chi-Lin is on the call, and Chi-Lin will talk about AIML impact from 5.5G to 6G. So let me introduce Dr. Chi-Lin. She is the chief scientist of wireless technology, China Mobile. She received her PhD from Stanford. She has won many, many awards. She's an IEEE fellow. Among hours, 2005, ComSec Stephen Rice. 2018, ComSec Fred Elder Prize. 7th IEEE SA Specific Outstanding Paper Award. In short, she has a lot of contribution, not only to the research, but also to the standardization. And this is my fellow colleague from IEEE, volunteer leader, and also an IEEE fellow. So with that, Chi-Lin, you are on the call. Can you hear us? Can you want to?
Yes. Yes. Can you hear me?
Yeah, I'll stop sharing. Please.
Okay, I'll share my screen.
Yeah, and Chi-Lin, you have 30 minutes.
Okay, you'll remind me when it's 5 minutes left, okay?
All right, sure. Thank you. So please, I want to make sure you can open your slide. Okay. Yeah, it's coming up.
Do you see it?
Yes. You can put it in the slideshow mode.
Yes.
Thank you.
I'm
All yours, Chi-Lin. Thank you.
Okay. So thanks, Shatai and Prabha, for this gracious invitation. It's really a great pleasure. I remember a little over a year ago, I believe it was in late May, I think you have organized the first IEEE Open RAN Summit. And I had the pleasure also gave a talk there. I remember that I was talking about open and smart RAN for 4G, 5G and beyond at that time. So this time we move a little bit further and be a little bit more focused. I'm focusing on the AIML impact going from 5.5G to 6G. Okay, so let's make sure that I keep the time well. First of all, of course, again, I'm from China Mobile, and currently our 5G network already has deployed more than 1.7 million 5G base stations, and we are serving more than 700 million 5G subscribers in our network. And this, I believe, it's about 1/3, a little bit shy of 1/3 of the global scale, both in terms of the network scale as well as the 5G subscriber base. And they are served with, we are very lucky we had the three frequency band in our 5G network. The main band is at the 2.6 gigahertz for most of the coverage and capacity. And then we also have a 700 megahertz band for extended coverage, wide area coverage, whereas 4.9 gigahertz band is available for really the hotspot when we really need, we are really in capacity crunch. Okay, and as everybody knows that 5G's one of the biggest value that we all envision, that we are all pursuing, is to serve vertical industry, enabling their digital transformation and upgrade. And in this case, currently, China Mobile has already, I think, succeeded with more than 20,000 vertical industry application cases, where you'll see some of the examples here, serving the mines, education, the power grid, transportation, high-speed, petrochemical industry, et cetera, et cetera. But 20,000 cases, our customers sounds like a large number, but really for the potential market, it is a drop in the bucket. And there is still a lot of opportunity and then a lot of challenges. Specifically, there's a very large variety of requirements and needs from different industry. On this page, I'm sharing some of the lessons we've learned. Of the most important requirements from various industry is agile deployment with their various needs. I highlighted some of the example cases here, which I don't think we have time to go over, but flexible customization with sometimes very unique needs. For example, in some cases, under almost 1 kilometer below ground, we have to deploy 5G network to serve our customer with the requirement of providing connectivity to 4K cameras spaced by every 6 meters, and then they require really significant uplink capacity for this network, to 1 gigabits per second for this network. And it also has stringent latency requirement to meet the remote control needs, and also very, in comparison, at that kind of a scenario, 30 centimeter accuracy of positioning is required. And in some cases, we have very strange coverage requirement for a very narrow space of 20 kilometers long, but only 3 meters high kind of a space. And so when you start talking with the different vertical industry, you will see that really there's a lot of extreme needs for the network capability, and also extreme needs for the flexibility to on the spot customize to their needs. And of course, they also require ease of use. Sometimes they require multiple network convergence. Sometimes they require the self activation of the SIM card, and also some performance visibility requirement, et cetera, et cetera. And also with all of that, most of the customers are also very sensitive about cost. So we also need to be very efficient with the resource, both in deployment and operation. And with all of that, actually, one of the solution is bringing intelligence into the network into our 5G network in all aspects, from offline phase when we do the planning, construction, maintenance, optimization, operation, and after we deploy it during the operation, we will also have to use the intelligent AI machine learning techniques to provide continuous optimization at all levels, at link level, at network level, and service level. Okay, with all of that in practice, kind of as needed, but not really a very systematic way, we take one step back and look at this chart that some of you may have seen it more than once from me, because I think this is really the heart of what is going on. From 4G to 5G to 6G, we have gone through CT only revolution all the way until 4G from 1G. Then we started our ICT, or now continue ICT convergence. 3 technology domains coming together to support the needs and the requirements that we are seeing. And in this process, of course, green, soft, open, and smart are the key themes. And as the operator, we see that it's absolutely important for us to be able to have the CI/CD/CT capability in-house and working close with our partners, but not becoming totally dependent on a end-to-end closed solution provided by traditional solution provider. And the AI, machine learning, cloudification, these are the key of the technologies that we will need to incorporate. And as I think both Ashutosh and Purvi also in different way have emphasized the importance of open ecosystem for the faster innovation. Okay, this is a quick overview of where we are in terms of AI machine learning related standardization effort progress. You see that in ITU, in ETSI, in 3GPP, and ORAN, there are various efforts already going on. Some are at still like conceptual level and framework level. Some are more into the actual functionality and architecture design. And I think, of course, the most important part that everybody would pay attention is what's going on in 3GPP. I have here, basically, I think, almost exhaustive, have included all of the AI machine learning related standard activity that has been taking place across the SA 1, 2, 3, 5, as well as, I think I missed SA6. I think there's some activity in SA6 related to AI machine learning as well, particularly serving vertical industries. Now, and of course, for today, I think we would focus on the RAN 1, RAN 2 related activity here. One thing that I would like to highlight is so far in the RAN, in 3GPP RAN working groups, the AI and machine learning effort has been taking, in my view, very conservative steps forward, mostly emphasizing on enhancing the data collection. And then they are starting exploring some of the use cases such as energy saving, load balancing, mobility optimization, etc. However, without much modification of the current existing RAN architecture. So it's still a kind of, I think, relatively conservative. And then I think RAN 1's effort is quite different. It's about the CSI feedback and channel estimation, optimization, and reducing the feedback. That I think it's not our main topic today. It's, I think, the main activity as far as Open RAN is concerned is much more RAN 3 related, as I'm showing here. There are two study items and work items, but they basically are some data collection and utilization enhancement within the current architecture. So in terms of the actually architectural functional framework, you'll see that since 2017, there was a proposal from WIA actually trying to echo with the NWDA in core network, proposing RAN-DA, which would be composed of the CODA and the DODA parts. There was an attempt of bringing AI machine learning element into a 5G architecture, which of course was not really accommodated in the eventual 5G standards. And then in ORAN, there is, I will, I guess, give a little more detail work about the RAN intelligent controller hierarchical structure, which is our additional new functional elements that are introduced to the RAN. And ITUT also had some framework work, but it was focusing more on the machine learning pipeline versus the sandbox type of concept. It's more of a general framework, not specifically related to RAN or not. And most recently in RAN 3, there is a AI machine learning kind of a functional framework for RAN intelligence being studied. However, if you look at this framework, it's really quite generic. Data collection, model training, model inference, actor. This seems to be a generic framework that doesn't matter whether it's RAN or anything, or it's at the even application level. This is I think it's too generic, this framework. Okay, now, so let's get back to, of course, what you would expect that I would spend most of the remaining part talking about, which is the progress in ORAN. Okay, ORAN from day one, when it was established in 2018, had declared that open, disaggregated, virtualized, interoperable, and intelligent RAN is the focus of their effort, which basically, in short, is the ICT Convergence in RAN. And so far, we are very lucky. We have enjoyed steady support of now close to 4,500 or around 4,500 very active global experts working diligently, delivering the necessary standards and the solutions. And you can see that our technical steering committee today is composed of 11 working groups, 5 focus groups, and 1 research group, and also an open source community, as well as a few other committee. And this actually is what those 4,500 active technical experts have been organized to deliver their work. And jointly, they have jointly completed over 400. Actually, as we're speaking, we have close to 500 technical documents, and among which it includes just over 100 current versions of different titles. Okay, now the intelligence part of the whole ORAN architecture, as you can see, it has the 3GPP, starting with the 3GPP's CU, CP, CUUP, DU, RU as the baseline, and there also is compliant with the 3GPP's interfaces among them. And in addition, there is the management plan intelligence provided by SMO, Service and Management and Orchestration. It's composed of 3 parts, the SMO, I will go into more detail in the next page, but it is this SMO work includes basically the OAM, intelligent OAM, and also the intelligent orchestration in the virtualized or containerized domain, as well as the non-real-time RAN intelligent controller, the non-real-time RIC. And this work is carried out in working group 1, 2, 6, and 10, the 4 working groups jointly working on this part, the intelligent management and automation. And then the near real-time RIC is providing the intelligent controls and the control plan, which is the work that the working group 3 is focusing on. I'll give a little bit more detail and also the update. This is the intelligent management, RAN intelligent management and automation part, which, as I said in the previous page, it's provided by what we call SMO functionality, which includes intelligent FCAPS through the O1 interface to all the RAN, other RAN element, and then also in the containerized or virtualized domain, the intelligent orchestration via the O2 interface. And then with A1 interface, it connects to the near real-time RIC from the non-real-time RIC. And within the non-real-time RIC, we have a R1 interface, or actually it's more like an API to support to provide service management and exposure services, as well as data management, as well as data exposure services, and also all the AIML flow within this part of the network. And our apps could be provided by the operator, by the vendor, as well as any third-party developers. And then between this non-real-time RIC and the near real-time RIC, the A1 interface is where the policy information, the data analytic, because the training will be mostly done in non-real-time RIC, whereas the inference will be probably exercised in near real-time RIC in most cases. So A1 will be where the necessary data, the necessary enhancement information, the policy and the control will be passing through this key interface A1. Okay, whereas the near real-time RIC that provides the control plan intelligence actually is structured with a E2 interface to all of the RAN functional nodes, including CU, DU, and others. And this part actually is where the fine-grained data collection of the RAN would be passed northbound, and then the fine-grained control actions would be passing southbound down E2. Whereas within the near real-time RIC, you will see that it's also a service-based architecture, just like the non-real-time RIC, and where the key interfaces upwards, you will see the O1 with the intelligent OAM, A1 with the non-real-time RIC, and also there is another new interface called Y1, which actually is an important interface that exposes the RAN analytics and the RAN data, of course, after cleaning and the necessary protection is done, to the Y1 consumers. the consumers could be our core network, our OAM, or our own internal services. It could also be third-party applications making use of valuable information that is exposed through Y1. And this is one of the very active current effort that is considered very valuable by our members. And then within the near real-time rig platform, XApps are the intelligent functions. Those could be data collection, cleansing, analytic, or it could also be the inference of specific applications. Okay, and very importantly are the near real-time rig APIs, which actually is the key. It's analogous to the R1 in the non-real-time rig. In non-real-time rig, R1 is used to serve, to host our apps over the platform capability, whereas here, a set of near real-time rig APIs are serving the XApps for the same purpose. And this part, the reason why I'm spending so much time elaborating on this is because this APIs was somehow the most challenging part for our members to reach consensus. The good news is finally this year we have published the first version of the APIs. So it's a very great progress there. And then I would like to share with you about our release planning with the feature package. The feature packages actually are a way that we group the necessary technical specs that's delivered by various working groups together so that they could either provide you smart capacity, enable new business models, or facilitate the network automation, and also provide sustainability and security, etc. The highly desirable capability that most of our operator members requested with high priority. So far, each of the release are composed of a collection of valuable feature packages. We have just published our release 3 at the MWC Barcelona this year, where 5 feature packages were included. That includes the RAN slicing, SMO, security, mass MIMO optimization, and the RAN analytic information exposure. Actually, you can see that leaving the security alone aside, 4 out of the 5 are all enabled actually by AI and machine learning in one way or another. And then currently, release 04 is being planned, where there are quite a few candidate features being covered. First of all, the enhancement of security, SMO, mass MIMO optimization, and the analytic information exposure are included. In addition, there are several new feature package candidates, including the RAN energy saving, shared ORU, or cloud resource organization, and the SMO intent-driven management, as well as AIML workflow for ORAC, plus 2 additional study items. And most of them, as I use boldface to indicate, are actually centered around AI machine learning capability, basically RIG and SMO enabled. And even some of the cases like shared ORU and cloud resource optimization that I did not boldface, they also require AI machine learning. So you'll see that AI and machine learning are actually the core of all the valuable feature packages for the value proposition to meet our.
Chi-Lin, you have about 5 minutes.
Left? Oh, okay, so I'll fly the rest. Okay, now just very quickly, our open source community composed of 13 projects, where actually 6 of them that I highlight here are all AI machine learning centric, okay? And actually, not only our open source community are delivering software code based on our technical spec, but also there is feedback based on the open source community's code experience. Some of the example also includes the feedback for non-real-time RIC on the A1 interface to our working group 2. And what I did not list here is we expect also important feedback coming back from not this one, but from the RIC as well as RIC projects to working group 3 as well. Okay, well, we have open labs that one East Coast, one West Coast from the open source community, and one in Asia Pacific area. They have a different emphasis, but RIC and XApp are actually very much highlighted. Of course, MVPC features in the East Coast lab will cover all of the intelligent cases. And currently, we are forming a supervised RAN blueprint with many partners throughout various open source community or program. Okay, and also worth mentioning is our OTICs, especially since this event physically taking place in Johns Hopkins in North America. You'll see that we have established so far 15 OTICs, the Open Testing Integration Center globally, 4 in Europe, 5 in Asian Pacific, and 6 in North America. I'm not going to spend time talking about the rest, but the ones in North America, especially the 4 latest one, very interestingly, are mostly, they are hosted by universities and the partners. And in addition, almost all of them, without exception, have all been actively working on RIC-related POC, not only non-real-time RIC, near real-time RIC, but some of them have actually moved even further to what we didn't dare to mention in the beginning of our ORAN architecture, which is the real-time RIC. Okay. Now, in terms of the, I think also some interesting sign to see is our global PlugFest from the early days, mostly in open front hall. Nowadays, RIC-related cases have becoming more and more popular in our recent global PlugFest. And I also want to use this opportunity to remind everybody that our 7th PlugFest is just starting, and our call for participation will run from August 14 to August 25, because the first phase was called for the hosting, which is completed. And the whole PlugFest, this is the fall 2023 PlugFest duration will run all the way until mid-November. So any of you, and also all of the, I think, ecosystem players, as well as the participants of today's event, you are welcome to join us in this exciting event. We have biennial PlugFest since last year. Okay, this is a case that I've shared in different occasions using RIC, non-real-time RIC and near real-time RIC together to provide the RAN slice SL insurance. I don't have time to go into detail. I just use a number to show you that with or without it, we could go from 70% satisfaction rate to 90%, okay, in 3 different slices on the same system. And then this is a security surveillance camera system using RIC, enable the bandwidth prediction and exposure to this video camera so that various video camera link bandwidth is predicted by the RIC system, and then that information exposed to the camera, and the camera would, based on that system, to automatically adjust its code rate. And you can see after adjustment, it provides a consistent frame interval for the receiver side, which is actually very important for the quality of the video receiver. Okay, and in terms of the actual deployment or trials, you will see that the global operators highlighted the ones that recently have been announcing their trial or plan to deployment that's associated with intelligence. The open aspect is much more.
You have 1 minute just to listen. Thanks.
Whereas the intelligence is now the new important the focus. But I have to say that we are still at the early stage of the actual standardization and the technical capabilities. Okay, our 6G research group was launched a year ago, and it's collaborating globally with many different associations. And so far, it delivered a few research reports focusing on native AI architecture and cross-domain AI, etc. And we have held already 3 workshops since October last year. The first one focusing on academic community, second one regional 6G program, the third one we just finished in June, focused on vertical industries. And the fourth one will be held in October in Phoenix, Arizona. And the focus will be on AIML, GPT, and large models. And I'm using this opportunity to call for all of your interest and join us, because our research group activity is open for non-members, especially if you are from academia. So there's a simple participation agreement that you sign, then you're welcome to join us. Okay, just some initial thought about going forward, what we need to do. Currently, most of the intelligence in our either the network in the fields or the current standards are all kind of a plug-in AI, not really native, and are all kind of separate AI in the core, in the edge, in the RAN or in the UE, and we need to have a unified end-to-end design. And also, currently, most of the cases are just use case driven. So in the future, instead of use case driven, we hope that it become a genuinely capability driven. And another one is best efforts to quality of AI services assurance. And just very quickly, initial thought about this quality of AI services, it must be multidimensional. It will have a multidimensional performance as well as the cost, as well as the security and autonomy level, etc. So this is some initial thought about how we can maybe specify the QoAIS indicators in the future and the quantitative analysis. Okay. Now, the last words is about intent-driven. I think intent-driven is very important going forward. And given that 3GPP, ETSI, TM Foreign, ORAN all have intent-driven related activity going on, still, I haven't seen actual solid detail because most of the work seems to be still at the conceptual level. And one idea that I would like to propose is how do we leverage the ChatGPT LLM advances today? Perhaps we need to have not LLM, large language model, but rather a large network model. And how can we perceive that? That's one thing that it's a thought for everybody to think about. Okay, finally, that's my concluding page. I think the future is very interesting because let's say the CT standards approach, the IT open source approach, plus the DT AIML and large X model, all coming together. I think the future will be very exciting. And let's all make good use of this opportunity and face the challenges together and find interesting solutions ahead. Okay, that's it. So did I?
I know, let me just, so, you always give a great talk, very comprehensive, and let me see if I can share that. So we didn't have any real keynote talk, so folks, please assume this is the keynote talk. Every speaker is important, but this is as the leader of Open RAN Alliance. Oh, there is some humming sound here. Can you turn that off, Purba? Let's see. So we'd like to, on behalf of IEEE Standards Association and IEEE overall, we'd like to thank you. This is a certificate of appreciation. We also have some, this is going to be sent back to you. I just want to show folks who are on the call, a small gift, speaker gifts for you. And Chi-Lin, thank you. Hopefully next time you can join in person if you're visiting United States, New Jersey, and Maryland, wherever. So with that, let's give a big hand applause to Dr. Chi-Lin.